All right, so we'll continue talking about life cycles, life cycle states and methods. We just finished looking at those methods in the previous video, and the 7 states and 6 methods. So now we'll look at how what the user expects when the activity moves from one state to another, right? Okay, so before that, let's go ahead and override the lifecycle methods. We have already done that for onCreate, but let's also add the log statement inside it. So remember, you used log in onCreate at other places, not shown here, but we used it to show what is the current die roll and what is the balance if the die roll is 6, right? So you should have the tag defined at the class level and so on. So simply add a log.d tag comma onCreate at the top of onCreate right after it calls the super.onCreate. And then add these methods onStart, onResume, etc., which basically override the parent method inside the class. So you'll have onStart. Let's go and put the log message in all of those. And all these methods should call their super dot corresponding method. So you have onStart, onResume, onPause, onStop, and onDestroy. Not exactly in that order on the screen here, but that doesn't really matter. Yeah. So why are we doing this? We'll look at what the user expectations are, compare it with the list you have made, in the previous video, and we'll use the log messages to see actually how the app moves between those states. And doing this and then playing with the app, creating or earning a bunch of coins, rotating the device, and pausing the activity, pulling up another activity in front of it. All of that will help you develop the understanding of these activity life cycles. So even beyond what we are doing in this video, please go ahead and just play around with these things and observe the log messages. Okay. All right, but once you are done with all of this, shouldn't take a lot of time. Let's go ahead and talk about what the user expects when the user or the system interacts with the app. So yeah, we'll discuss 3 broad scenarios. First of all, the user goes to the home screen, right? So user is using your app for some reason. He or she, they want to go to the home screen, open another app, or they're just done with it, so they go to the home screen, right? So what should happen in that case? Let's simulate that, by the way. So launch the app, earn some coins. So you'll see log messages corresponding to that, and this is what you will see if if we don't show the log messages. This is what you will see at this point. You'll see onCreate, onStart, and onResume. By the way, I'm assuming that after you added the overridden lifecycle methods, you launch the app again, right? So that's the assumption here. Otherwise, you won't see these log messages. All right. So yeah, so you see onCreate, onStart, onResume as expected so far. Next, press the home button. And before looking at the log messages, just think about what messages you should be seeing here. So remember, it should go from the resume state to the pause state and then to the stop state, because the stop state is one when it's completely invisible, right? So that's what you should see. So you'll see on pause and on stop being logged. That is, that they were called. And then return to the app. So how do you return to the app? One will go to the recent screen, which is the square at the bottom of your phone, and it will show you a bunch of apps you have open, and from that you can select it. Okay? Or you can go to the icon of your app in the home screen or the launcher screen, and click it to open it from there. Okay. Either ways, uh, again, you can think about what should happen. You should go from the stopped state to the started state, and then to the resumed state, because you're getting the activity again back at the top, ready to interact with the user. So you should see these log messages as expected. And what is the state of coins and the dice button? So you'll see your number of coins, and well, you'll expect, first of all, you'll expect the number of coins and the die to maintain the state. And in fact, it is maintained. So, a check mark on that. All right. Now, we said the app can be killed when it's in the stop state, right? And it's difficult to simulate that. You can't necessarily generate a scenario where the system is so crunched on resources that it has to kill an app, a simple app as ours. But there is a way of testing it or simulating it at least. So let's take a look at that. Okay. So, by the way, this is called a process death. So a process, like the system process that has your activity running, is killed by the system for whatever reason. And to simulate that, you'll have to do something on the device that you're testing or running your app on. Okay. So go to settings, then developer options, and then apps, and under that, enable don't keep activities. By the way, if you are using the emulator, you have perhaps not enabled developer options. How you do that? You go to settings and click on, yeah, I think I should be, click on About Phone for 7 times, and then the developer options are enabled. Okay. Inside that, you should go to the apps and then enable don't keep activities. So what this will do is, this will basically kill the activity as soon as it goes to the stopped state. Okay. All right. Next, do the same thing. Launch the app, earn some coins, press home, and you will, you'll see on the on create, on start, on resume, but then immediately on pause, on stop, and on destroy. So your app is destroyed at this point. You return to the app, you won't find it in the recent screen, so go to the home screen and click the icon. You return to the app that way, and then what does the user expect? Well, the user did not know that the activity was destroyed behind the screens. So the user still expects the same UI state to be retained. But will that happen? What do you guess? Yeah. So since the activity is destroyed, the value of the instance variables will not be retained, right? So yeah, when you return to the app, you'll see on create, on start, or on resume, but the UI state is not restored. Okay, so this is a bug um, in our app, right? So, and this was not caused by rotation. So this is perhaps another bug in our app. Okay. Yeah. So once again, yeah. So at on create, the OS has created a new activity, and previous one was completely erased. Let's now look at the second scenario, rotating the device. We have already seen that, but let's see what the log messages are. Okay. So yeah, to do this, go back and disable don't keep activities. And then again, launch the app, earn some coins. And now um, at this stage, you will again see the on create, on start, on resume, but then rotate the device. And what do you see? You'll see 6 log messages: on pause, on stop, on destroy, and then quickly on create, on start, and on resume. So rotating the device not only destroys the activity instance, but it also recreates the activity instance. That's why you see, you don't really see a difference when you rotate the device. Um, of course, the layout will perhaps look different, um, but it's supposed to be transparent to the user. But then what does the user expect? User has just changed the device angle, the device orientation, because they find it more convenient in this position than the previous one, portrait versus landscape, whatever it is. But now we are saying, um, but yeah, I mean, the user would not expect the UI state to be lost, right? But unfortunately, as we have seen, it the behavior as of now, which is the default behavior, where the developer has not really added anything, does not match the expectation of the user. And what's the reason? You perhaps guessed it already. Again, you can see the on destroy and on create. So once again, the OS has created a new activity instance, erasing the previous one completely. So this is the source of our first bug. Okay, we'll come back and see how to fix it soon. All right, now let's look at the third scenario where the user herself finishes the activity. And this is how you can do it. So once again, launch the app, earn some coins, but next click on the back button. So back button is this, in most devices, you'll find it as this arrow on the left. So the square on the right was the recents button through which you could go to the recent apps and come back to an activity. But the arrow button here or the triangle button here is the back button. You click that and you're basically saying, kill this activity. I'm done with this activity. You can finish it. I'm no longer interested. This is one way of finishing the activity. What are the other ways? I'll let you guys figure that out. There's, of course, a bunch of material on the internet to go and figure that out. Okay, now when you click that, you will go to the home screen, because that's where we came from. And now you launch the app again. So from the home screen, you'll have to go and find the app's icon, and that's where it will be. It will be launched, right? So once again, what do you expect? You'll find on pause, on stop, on destroy called when you click the back button, and then on create, on start, on resume called when you launch the app. Okay, makes sense, right? From our understanding of the app activity lifecycle states. So now the question is, what is the user's expectation at this point? Does the user expect the UI to return to the same state? And the answer is a bit tricky on this because it depends on the actual functioning or behavior of the app. It's not general as in the case of rotation. So I would say in our case, yes, perhaps the user expects the number of coins to be restored, right? They may want to keep coming back to the game and play with the coins they had earned. So at least that part, if not the value of the die, they would expect to restore. And that is not happening. But this need not be true always, because when the user clicks the back button, what she is saying is, I'm done with this app or this activity at least, and I don't really care what happens to its UI when I'm when I'm finishing it, right? So in general, user does not expect the UI state to be restored when they themselves click the back button, but there could be some information that should persist over several such sessions. Perhaps even when the device is shut down, right? Um, you would not want to lose the number of coins. For example, you would not want to lose your bank balance if you closed the app or if you rebooted the device or something like that, right? So um, I think that example is an indication of what needs to be done in that case. The data has to be somehow externally stored. So we'll come to solving this problem. Oops, we'll come to solving this problem a little later, but we'll try and solve the previous two problems, that is the rotation and process death, um, in next few slides. Okay, but yeah, this is what the user expects. Okay. All right. So let's talk about what happened there when you rotated the device. Now, that is called a device configuration change. Okay. Device configuration is a term for several things that describe the device. One of them is this orientation, whether it's in the portrait mode or the landscape mode. And portrait mode is defined, where the width uh, is less than the length, and landscape is the opposite. Okay. Um, Device language. So in your system setting, you have a language for the phone. It could be English US, it could be French, Spanish, Hindi, or any of the languages that the Android system supports. Okay. And all such things, they together create the configuration of the device. And um, if any of these is changed, the device basically has to recreate a lot of things. And we'll see why. So you might have seen many apps provide a different layout for layout and portrait orientation, right? Um, so, and the reason is basically, let's say the portrait is the default one, but then it does not render well when the device is rotated. So maybe there is a lot of things, a lot of lengthy things, more things put lengthwise, one below the other in the original layout. And when the device is rotated, that doesn't look pretty on the landscape layout. Plus, there is a lot of white space on either sides, left and right, in the landscape layout. So you as a developer may want to put the same widgets at different places, so the user can interact with the same widgets, but in a more user-friendly, more attractive, pretty way. Okay, so that is uh, a simple and perhaps obvious example of why we need or why the device handles device configuration change like this by using another resource. Um, so how do you create a portrait versus landscape layout? You basically have to define another XML file, which we'll get to in a second. Okay. But yeah, so any such runtime configuration changes. By the way, yeah, device language change also. So consider a bilingual person who say maybe travels between two areas of different language predominance, and that person changes the device language when going from one region to another. Right? Let's say more Spanish speaking parts of the US, or goes down in the goes to Mexico over the southern border, or let's say goes to some French speaking parts of Canada, things like that, right? And there the user wants to switch the phone language to French, Spanish, or whatever, based on those examples. And so when she does that in the system setting and comes back to your activity, she expects the activity also to switch to the language of the device, if it is supported, of course, right? So that is also when the entire activity should be destroyed and recreated. So let's look at this following bullet group here. So, such runtime configuration changes, operating system destroys the current activity, looks for the resources that are better suitable for the new configuration, like portrait versus landscape or change in the language, to display the strings in that language, right? And then recreates the activity with those resources. So this is what is happening in rotation as well. Okay. Of course, we don't have an alternate layout for landscape. So the OS basically picks up the same layout, which we used for portrait, but it has destroyed and recreated the activity instance nevertheless. So this is what is causing the destruction and recreation of the activity instance, which is leading to the bug that we saw in the first place. Okay. All right.